Video on lists. So now we are going to see this inbuilt data structure, and lists help us organize our code. Basically, it groups a lot of variables together under one umbrella. Okay, we'll proceed this by an example. So let's say you are going, for birthday shopping. So you would like to have a shopping list. And list in Python is pretty much parallel in meaning to what lists do in everyday life. So you want to say something like, all right, shopping list is equal to, as of now, there is nothing. So you just initialize that with square brackets. All right, let's just go ahead and quickly print the type of shopping list. Remember, type can be used to find out what data type does a particular object belong to. And we get that this is of the class list. So things are working fine now. All right, now let's go ahead and add some items to our list. Okay, let's say the cake, the first and foremost important ingredient of any party. And let's say, I don't know, balloons. Okay, and probably pizza. So we have some three items right now. The class of the type of shopping list is not going to change. What we would be interested, is in knowing, okay, how many items have been added. All right, so how many basically members are there in the list? So for that we use this function called len, which is short for length. Okay, so print len of shopping list, and this will give us, you can expect, 3, because there are 3 elements indeed in the shopping list. Fine. So, well, this is all working fine right now. Let's just, think about then, are elements indexed? Which means, what if I ask the question, okay, what is the first element in the list? Can that be answered? Because the first element is cake. So, if I just say the first element, so if you pass in a way, that index 1, can I get cake back? So, well, obviously you can. Okay, I'll just actually comment these out right for now, because there will otherwise be too many print statements. Print shopping list, and you want the first element. Let's say you want cake, so you print it out. You just pass this index 1. What is the syntax? You type the name of the list, you put the square brackets, and in that square brackets you put whatever index you want to get the value of. All right, so you would expect to get cake, but what you would instead get are balloons, which clearly suggests that, hey, indexing actually doesn't start from 1, it starts from 0. So cake is not at index 1, it's actually at index 0. All right, so counting in a way begins at 0 in Python, and actually in majority of the programming languages that at least I have the experience in. So, well, yeah, if we do shopping list of 0, we are going to get the first element. So this is an important idea, which is indexing. Now, I would like to point out here, that there is actually something called as negative indexing as well. So for any element that you see in Python, there is usually a positive index and a negative index. Both of them can be used to refer to the same element. For example, here I would just demonstrate very quickly. Even if I do shopping list of -3, we are going to get cake. All right. But I would leave negative indexing, for you to explore on your own. It's a cool concept, and sometimes it gets some questions done somewhat easily. All right. We are now going to see the membership test. All right. So membership test basically asks the very simple question: does this particular member that we are talking about belong to the list that we are looking in? All right. So the syntax is very simple. First, you have to type the member that you're looking for. Let's say we are looking for cake in shopping list. As simple as that. If cake exists in shopping list, you're going to get true, otherwise you're going to get false. Again, make sure that this is case sensitive, because capital C and small c have different codes actually. Python is case sensitive, and you do indeed get cake, which is true. Let's say you're looking for something else. I don't know, let's say you thought of ordering, I don't know, some drinks, and you just say print drinks in shopping list. Currently there is none, so you get a false. That is for membership. All right, now comes to the part of looping. So what if you want to print each and every element in the list? All right, first of all, what will happen if we just print the shopping list, straight, just shopping list, nothing else? Well, we do get actually all the elements in the list, but you see that they are printed as members of a list and not individual members. So this is okay, for viewing the contents of the list, and it has its own applications. But many a times we would need to iterate over each and every member of the list, and actually do some processing on that. All right. So for this, you can obviously use a for loop and a while loop, but I think a for loop is usually just more preferred in such cases, because we are going to loop not over the indices but directly over the value, which means that, look, there are two ways to loop over a list. Okay, one is that you loop over the indices, which are like 0, 1 and 2. Okay, the second is that you loop directly over the values, which would be something like, cake and balloons and, pizza. um, Again, this one is actually more granular, but if you're just printing out and doing, some simple processing, then I think, this one usually actually makes your code look simpler and easy to understand as well. So I'll just, use the second one. So the name of our list is shopping list. So we have to give some name. Remember, whenever we need to have a loop variable inside of a loop. It could be like I, J, anything. Since we are talking about sort of, an item in a shopping list, so I'll just call it item. So for item in shopping list, all we're going to do, look, so the for loop syntax doesn't change. Remember this colon, and the indentation that follows it. For item in shopping list, you just print item. All right. And now that prints out all the items that you had. Fine. So, well, this is cool, working good, right? You can also, actually make some conditional checks, but, I'll actually not go over that thing right now. For example, let's say, you can take that as an exercise. Let's say you just wanted to see, okay, which items are actually at least like four characters long, or which of them end in a vowel, or, some other type of a thing. So you can actually use some conditions inside of the loop so as to get more sophisticated and, specific outputs. All right, so now we will come to actually, mutating the state of our list. So as of now, list was created at the top at that position, and once it has been created, we are actually not changing it, right? That's just there. We are just accessing it. Reading is a harmless operation, but now we are going to, sort of update our list. Fine. So let's go ahead and say that, all right, we, have our list. I'll actually write this code right over here so that the list is visible. Since this code is commented out, so the order is not at all important. So let's say someone gave you the shopping list. So you do not have access to the place where the list was actually, declared, but you still have access to the shopping list. So you can change the state of it. You can mutate it. So let's say, you now want to add drinks to the shopping list. So you can do just like shopping list dot append. You want to add drinks, right? So just add drinks, and now just go ahead and print shopping list. You're going to get the, let me just run this code. Yeah, you're going to get that, see that drinks has also been added, right? But this drinks got added at the end, right? It's not alphabetical, no nothing. It has to be added at the end whenever you use an append function. So this brings us, is this a sort of a limitation? It depends upon the case, all right? For example, in many of the cases, new elements get added, at the back. It's a pretty standard approach, but sometimes you may need to actually insert an element at a specific position. All right. For example, let's say drinks have been added now, and let's just say we are trying to add, some other thing. Let's say snacks. Okay, and we want snacks to come right after balloon and between pizza. Okay, so in our list over here, snacks should come somewhere over here. All right. I hope you guys are able to see this cursor, this highlight. So we would like snacks to come over there. Fine. So let's think about the index. Cake is at index 0, balloons is at index 1, and if snacks were to come after balloons, it would be at index 2, right? So what do? We do shopping list dot insert. Then let's look at the documentation here. It asks, okay, at which index do you wish to insert? We say we wish to insert at index 2. What do you wish to insert? We wish to insert snacks. All right. And now if you print shopping list, you see that indeed snacks get added at the correct position. All right. If you did shopping list dot append snack, what would happen is, first of all, this argument is not necessary because append by default means that you'll be adding, at the back, and snacks would have followed drinks. Fine. So I hope you're able to understand up till here. We still have, just a few more functions to see. Again, list is, a huge topic, and I would really encourage you to, explore it on your own also a little bit. But yeah, we do have actually some other things to see as well. Okay, so let's see, some other requirements comes, and instead of cake, you wanted to change that cake to something like, let's say chocolate cake. You wanted to be more specific. So this is the idea of updating an element of the list, right? The difference between appending and inserting versus updating is that append and insert, both of them are actually increasing the size of the list. They are increasing the length of the list, right? A new element is added. Whereas if you want to just update a list, maybe we don't want to add another element. Maybe just we want to replace an element with a new one. So what we do here, we said that okay, shopping list of 0, right? So the cake is at index 0, so we can just say shopping list of 0, which means that this variable cake, you replace that by chocolate cake, because cake can be sort of ambiguous, right? And like if people get strawberry cake and all, it's, I don't know how many people are going to enjoy that, but chocolate is, it's pretty safe, right? So if you run this now, you see that the first item has been updated to chocolate cake, and all other items remain the same. So updating, does it add something to a list? No. Does it remove? No. It merely overrides. That is why it is updating an element. And last but not the least, let's also see how to remove something from the list. So, because there's too much snacks and all, let's say you just wanted to get rid of, I don't know, pizza. Okay. So you just do shopping list dot remove. Let's look at, the documentation over here. It says self, well, self is basically shopping list, the object that you're calling on, and the value. So which value do you wish to remove? Whenever you have a doubt, and in case you are using, an IDE like PyCharm, so you can always, hover on top of that and see, okay, what all values are expected. So over here, a value is expected, which basically means, okay, which, what element do you want to remove? So we want to remove pizza, right? So you just do list.remove pizza, and you see that pizza has indeed been deleted. So append, insert, and remove, all of them alter the size of the list, the length of the list. But updating doesn't affect that. Uh, so this is, a basic introduction to list. There are other concepts in lists as well, which will be helpful if you actually learn them. One important concept that would be really helpful, but I would leave it for you to study on your own, is basically slicing. Okay, so how to take slices of a list, how to take substring, it's very similar to how to take substrings of a string. You can actually visualize string as a list. Anyway, that is it for this video. I hope you have liked it, and thank you. I'll see you in the next.